I welcome all of you to the lecture 12, and in today's lecture we'll be talking about the interpolation formula, and today we'll be talking about the Newton's method of interpolation. Since we have already discussed in the previous class forward difference tables, the backward difference tables, the central difference table, and in fact the divided difference table, we'll be making use of these tables to do what's known as the interpolation. Before I go ahead with the interpolation, let me explain what we mean by the interpolation. For example, I am given the values of x, and corresponding to the values of x, I am giving the values of y. That is, for x is equal to 1, let's suppose the value of y is 2. X is equal to 3, the value of y is, say, for example, 9. X is equal to 5, the value is, say, for example, 7. X is equal to 7, the value is, say, for example, 12. Fine. Now I am given the different values of x. Corresponding to the different values of x, we are also given the different values of y. Now the question is, say for example, we are given what is the value of y at x is equal to 5.5, say for example. When x is equal to 5.5, what is the value of y? Fine. This process, the process of obtaining the value of y for a given value of x, as well as with the help of the given data, is known as the interpolation. This is called the interpolation. Okay. So what we have, we are given a tabulated data. So we do have the data in hand. Okay. So we have these values of x and y. This is the data in hand. And with the help of the given data, we need to find the value of y for a given value of x. The technique for obtaining the value of x, okay, the technique for obtaining the value of y for a given value of x, as well as for the given uh, for the given tabulate for a given table of x and y is known as the interpolation. Okay, the first interpolation technique that we'll be using is called the Newton's forward difference interpolation formula. So this lecture deals with the understanding of Newton's forward difference sorry Newton's forward difference interpolation formula. What is the Newton's forward difference interpolation formula? Okay, so what as I just stated, that will be given the values of x as well as the values of y. Okay, so the technique is, for the given values of x and y, okay, we have the values of x and we have the values of y. The technique is assuming a polynomial, or assuming a function, or we can say deriving a function, I should say. The concept is deriving the function to which we give x as input and obtain y as output. What I mean to say is, the problem is quite simple. We are given the values of x and the values of the y. Okay, so for x is equal to 1, y is 3. For x is equal to 2, y is 9. X is equal to 3, y is 6. That's okay. Now, all of a sudden, we are being asked, if x is equal to, say, for example, 2.5, what is the value of the y? What we will do, in between the given values of x and y, we will derive a polynomial, okay, an equation, we will say. We will try to derive the polynomial or the equation between these x's and y's. Okay, for example, we will derive y as a function of x for a given set of data. Now, once we have obtained the polynomial or the equation between the given values of x and y, to the polynomial we have obtained or we have derived, we will give x as an input and will obtain y as an output. Say, for example, the question is it now reduces to finding the polynomial, okay, or finding the equation by which this variation of x and y can be adjusted or can be represented, I should say. Okay, so if we are obtaining an equation y as a function of x, okay, to that y as a function of x, if we give x is equal to 1, it should give us y equal to 3. If we give x is equal to 2, it should give us y is equal to 9. If we give x is equal to 3, it should give us y is equal to 6. And if we give x is equal to 2.5, it should give us the perfect value of the y. This is the trend. And this we do with the help of Newton's forward difference interpolation formula. So what Newton's forward difference interpolation formula says, it says, let y of x be equal a1 plus a2 x minus x1 plus a3 x minus x1 into x minus x2 plus a4, let me write it here, x minus x1 into x minus x2 into x minus x3 plus a5, or I will write here so on, plus so on, plus the last term will be, see, when we are having the second term here, second coefficient here, we have x minus x1. We have third coefficient here, we have x minus x2 is here, okay. We have a4, the fourth coefficient here, so we are having the third, okay. So what we'll be having, we'll be writing the last term will be a n plus 1, okay, into x minus x1 into x minus x2 in product, so on, into x minus xn. Okay, what is the reason for writing a n plus 1? Because when we are, what we are doing is the Newton's forward difference interpolation formula. It assumes that the function y of x is tabulated. It is tabulated at n plus 1 equally spaced points. Equally spaced points. We'll get to know about it once we will doing a problem. But till now, let's hang on for some time. Let's say that this is the y of x is equal to a1 plus a2, so on. This is the Newton's forward difference interpolation polynomial that assumes, or that gives, for what are these x1, this is the given value of x1, this is the given value of x2, this is the given value of x3, okay, this is the given value of xn, okay. So we have to find the value of the y at some other value of x. Say for example, as I was telling in the previous example, x is equal to 2.5. So as we substitute x is equal to 2.5 here, 2.5 here, we should be able to obtain the value of y, okay. So how the Newton's forward difference interpolation formula starts, it says, let us assume that the function y of x is tabulated at n plus 1 equally spaced points, and y of x is equal to this, okay. Then at x is equal to x1, at x is equal to x1, the value of y becomes equal, this term becomes 0, this term becomes 0, this all the terms become 0, y becomes equal to a1, okay. At x is equal to x2, because x1 x2 are the given values, y becomes equal, at x is equal to x2, okay, y becomes equal a1 plus a2 into x is equal to x2, this is x2 minus x1, rest all the terms are 0. At x is equal to x3, the value of y will become equal, yes, a1 plus a2 into x3 minus x1 plus a3, x3 minus x1 into x3 minus x2, okay, and so on, and so on, okay. Now what we are writing is something very important, that we are given the values of x. We have x1, x2, x3, x4. Okay, so they're equally spaced points. That is, if x1 minus x2 is h, x3 minus x2 is also equal to h. This is also equal to h. And x3 minus x4 minus x3 is also equal to h. Like in the previous case, we had x1 is equal to 1, 2, 3, 4. Okay, the difference is same. Therefore, we can write this entire expression as, we can, let me write. Therefore, the entire expression can therefore be written as, we have x, so this is x2, okay? This is x2, if this is x2 minus x1 is h, that is, I will write here, x2 minus x1 is equal to h. Also, x3 minus x2 is also equal h. Similarly, x4 minus x3 is also equal h. But there is one important thing that we should learn. Can we write this as, this is x3 minus x2? Can we write this as x3 minus x2? x2 is equal, x2 from this equation can be written as x1 plus h is equal to h. x2 from this equation can be written as x2 is equal x1 plus h. Okay, so we can write x3 is equal x3 minus x1 minus h will go to, that's equal 2 times h. Okay, so x3 minus x1 is equal to h. We can also write this as, x3 can be written as x2 plus 1. x3 is 2 plus 1. 3 can be written as 2 plus 1 minus x1 is equal to h. From this, we can derive a general expression. We can write this as x I plus 1 minus, okay, I'm writing this as xi, okay, where I is equal, where I is equal to, okay, xi minus x1, okay, this is x1, is equal 2 times h. And if you look your I here, I is equal to 2. So this can be written as I into h. This is about the intervals, I into h, or I is equal to h. Okay, fine. Or we can also write this as, in the general expression, I would like to write this in this way. Okay, this can be written as, this is 2 plus 1 minus x1 is equal to h. Okay, so I can write this as, if I call this as, I will call 2 as I will call this as m, or I will call this I as I, this one we represent by I, the general expression, and 2 is m. Okay, so this is I, this 2 is m. Okay, so from here we can write x m plus I minus xi is equal to m times h. This is quite easy. This is not too difficult to understand. If you see here, if you come here and see x4 minus x1, that's equal h plus h plus h, that is 3h. Okay, so this can be written as x 3 plus 1 minus x1 is equal to 3 times h. That is, x3 is here, so you have 3 here. In the same way, you have m here, you will be having m here. That's this quite easy to understand. Okay, so based on this, we have written, we can write this as, if you look here, you have x2 minus x1, that's equal to h. x2 minus x1 is equal to h. Then you have x3 minus x1. Okay, x3 minus x1 can be written as, so this is quite important now. Okay, so you have x3 can be written as, this is x3 minus x1, this is h plus h, so this you can write this as 2h. So this you can write as 2h, and x3 minus x2, x3 minus x2 you can write as h. Okay, so what I will do, I will generally write all these expressions now as, so we had y1 is equal to a1, we had y2 is equal to a1 plus a2, x2 minus x1, and we had y3 is equal to a1 plus a2, x3 minus x1 plus a3 into multiplied by x3 minus x1 into x3 minus x2, and so on and so on. Okay, so now we are saying that x3 minus x1, we just got an expression that xm plus 1 or I plus m minus xi is equal to m times h. This was the expression that we just obtained. Okay, so based on this expression, we can write this as, you have x3 minus xi x1, you can write this as x 1 plus 2 minus x1 is equal 2 times h. This is m into h. Okay, so you can write this as 2h. This you can also write as 2h, and this you can write as h. Okay, okay, that is fine. Okay, okay. Now the question is about writing this y1, y2, and y3. Therefore, in terms of h, we can write, therefore, is this much. Based on this, we can write our y1 is equal to a1. No problem with this. And our y2 is equal a1 plus a2 into h. And our y3 is equal a1 plus a2 into 2 times h plus a3 into 2h into h. Okay, so on. Okay, if you look at the forward polynomial which we had assumed, it was y of x is equal to a1 plus a2 x minus x1 plus a3 x minus x1 into x minus x2 plus so on, plus an plus 1 into x minus x1 into x minus x2 so on into x minus xn. Okay, so this is the first value of y, this is the second value of y, this is the nth value, n plus 1th value of y. So we'll be having y n plus 1 will be equal, okay, that will be equal to a1 plus a2 into 2h plus a3 into 2h into h plus a4 plus so on. I will write plus so on because terms are increasing, plus the last term is an plus 1, x minus x1 is h. Okay, so you have x minus xn is n times h. Okay, so it is h into 2h into 3h into 4h. So I will write this as nh into n minus 1 into h into so on. The last term will be h. Okay, because you have x minus x1, that is h, x minus x2 is 2h. Okay, so this is h, this is 2h, then it will be 3h, then it will be 4h, then you have x minus xh, x minus xn, that is n times h. Okay, so I have started from nh. Okay, then it will be n minus 1h, n minus 2h, n minus 4h, and finally it will reach to h, that's here. Okay, so this is yn plus 1. Okay, so from here we can simply say that y1 is equal a1. Can we also solve for y2? For us the coefficient a1 which we are in the assumed polynomial is equal y1. And what about the a2? We can also write this a2 as, therefore let me clear some space here. We can also write, therefore now our y1 is equal to a1, and our y2 we can write our y2 is equal a1 plus a2h. Okay, therefore from here we can write y2 minus a1 is y1, okay, divided by h is equal a2. Okay, so we have a1, we have a2. Similarly, we can talk of a3. We can also solve for a3. Okay, so as far as the a3 expression was concerned, if you recall, our expression for y3 was, I think it was y3 is equal a1 plus a2 multiplied by x3 minus x1 um, uh, plus a3 into x3 minus x1 into x3 minus x2. Okay, so we can write this as y3 is equal to a1. A1 is y1. Okay, plus, if you look at this a2, x3 minus x1. Okay, or this is a2. I will write this as a2, no problem. X3 minus x1 is 2 times h. Okay, a3. Yes, a1, a2, and this is minus a1. Okay, so we have a3. Okay, so plus a3, no problem. X3 minus xh is 2h, and this is h. Okay, this is 2h square. Okay, so from here we can find the value of this a3 because we already know the value of a2. Okay, so we can at least say that the value of a3 becomes equal y3 minus y1. I will write y1 minus a2 minus 2h. A2 is our y2 minus y1. That is y2 minus y1 divided by h, and you have 2h. Okay, whole divided by, so this is y3 whole divided by 2h square. Okay, so if we went on to solve this, it will be y3 minus 2 times y2 plus y1, okay, divided by 2h square. Okay, so at least we can, so these are the different coefficients we are trying to find. Okay, if you look at a1, our y1 was clearly equal to a1. Okay, and our a2 was equal to, or I can write it here, I can write this as a1 is equal to y1, and our a2 is equal to y2 minus y1 divided by h, and our a3 that we just obtained is equal y3 minus twice y2 minus y1 divided by 2h square. I can write that as 2 factorial h square. Okay, so from here I can also obtain the values of other a's coefficients. We can obtain the values of other coefficients as how to obtain the values of other coefficients. We can now say that an plus 1, how to find it. Okay, a1, a2, a3. We can also write the expression for a n plus 1 is equal. So you see, you have a3, you have y3, you have a2, you have y2, you have a1, you have y1. So an plus 1, I will directly write yn plus 1. Okay, when you had a3, you had minus 2y2. So you have an plus 1 yn minus, it will be uh, yeah, it will be, so you have 3, you have 2, you have n plus 1, here it will be n, ny, here you have n 2y2, here you have 1y1. Okay, you have 0 1y1. Okay, so here we can write a3 y3 minus this an plus 1 is yn plus 1, then you have ny okay, plus many terms, plus the last term here is y1. I will write y divided by You have 2 factorial, here you have 3, you have n plus 1, it has to be n factorial. Then you have 2 factorial and h square, so it will n factorial raised power h raised power n. As you have 1 factorial h raised power 1, it will be n factorial. Okay, we have already dealt with the forward difference table. Okay, what is the forward difference table? That's very important for us to understand. So these values of y will keep in mind. What is the value of y, a1, a2, a3, an plus 1. Okay, we also have, as we in the previous class we talked about the forward difference table, we also have the forward difference table in mind. What is the forward difference table? Let me simply recapitulate the table today. In the forward difference table, like you have we are given the values of x1, x2, x3, x4, x5, and we are given the values of y, y1, y2, y3, y4, y5. y2 minus y1, it is delta y1. y3 minus y2, it is delta y2. y4, it is delta y3, and this is delta y4. Okay, then we take the second difference, delta y2 minus delta y1, we write this as delta 2 y1. Then this is delta 2 y2, this is delta 2 y3. Then we again take the difference between them, then we write delta 3 y1, delta 3 y2. Then we take the difference, it will be delta 4 y1. This is how the forward difference table actually works. Okay, so we want to make use of this forward difference table. How we can you make use of this forward difference table? That is, we clear this all. In the forward difference table, we had y1. Okay, we have y1 is equal to a1. Okay, and we have a2 is equal, what is a2 equal? If you look at a2, our a2 was equal y2 minus y1 divided by h. Okay, so it was equal to y2 minus y1 divided by h. Okay, so use the forward difference table, x1, x2, x3, so on. So you have y1, y2, y3. Okay, so when we have y2 minus y1, it's called delta y1. It is the first forward difference. Okay, so we can write this as delta y1 divided by h. Okay, this is our a2. In the same way, if you look at your a3, a3 is equal, or a3 is equal to y3 minus twice y2 plus y1 whole divided by 2 factorial into h square. Okay, so this expression can also be written as, okay, this expression can be written as, this is, we can write this as, this is y3 minus y2, okay, minus or plus y1 minus y2. Okay, because this is y3, that's here, twice y2 minus y2 minus y2 is minus 2y2. Okay, and you have plus y1, that's here, divided by 2 factorial into h square. Okay, so if you look at y3 minus y2, so y3 minus y2 is the first difference. Okay, this is delta y2 is equal y3 minus y2. Then when we take the second difference, it will be delta y1 minus delta y2. That is y3 minus y2 minus y2 minus y1. That is equal y3 minus y2 plus y1 minus y2. And this second difference is defined as delta 2 y1. Okay, so that's here. This expression is here. This can be written as delta 2 y1, this is the second forward difference, divided by 2 factorial into h square. In the same way, we had the last expression was, our last expression was what we call as h raised power n. In the last expression, we had an plus 1. Okay, that therefore can be written as, delta n y n divided by n factorial into h raised power n. The reason is quite simple. You can look at a2 is here, let me, your a1 is equal to y1 and a2 is equal to delta y1 divided by h. A3 is equal to delta square y1 divided by 2 factorial into h square. Okay, therefore an plus 1 will be delta. You have 3 here, you have 2 here, you have n plus 1 here, it will be n here. Y, okay, 1. Fine. You have 2 here, you have 2 here. So it will be n factorial h raised for n. This is the an. Okay. Substitute the value of a1, a2, a3, a4, a5, an plus 1 in the given polynomial. Okay. The polynomial that we have is y of x is equal a1 plus a2 x minus x1 plus a3 x minus x1 into x minus x2 plus so on. Last term is, let me write it here, plus an plus 1 into x minus x1 into x minus x2 into x minus x3, so on in product into x minus xn. Okay, so this is how it works. Therefore we can write y of x is equal to a1, or a1 is equal to y1 plus a2, our a2 is equal delta y1 divided by h, okay, into x minus x1 plus a3. A3 is delta square y1 divided by 2 factorial h square into x minus x1 into x minus x2 plus an plus 1, that is delta n y1 divided by n factorial h raised for n into x minus x1 into x minus x2, so on into x minus xn. Fine. Now we have x minus x1 by h, x minus x1 by okay, 2h. So what we'll do, we'll make an assumption. Let x minus x1 divided by h be equal to u. Okay. Therefore we can write, therefore x minus x1 becomes equal to u times h. Therefore x minus x1 becomes u times h. Okay. In the same way, we also have the term like x minus x2. We can write that as x minus x2 can be written as x minus x2 is equal, what is x2? X2 is equal, this is x1, x2, x3, so on, different values. X1 minus x2 is equal to h. Therefore, x2 will be equal, x2 minus x1 is equal to h. Okay, therefore x2 will be equal x1 plus h. Okay, fine. So x minus x2 is, that can be therefore written as which implies x minus x1, which is equal x. X is equal, from this formula, x is equal x1 plus uh. Then we have minus x1 minus h. This is minus x1 minus h. Okay, this can be written as x1 will go, this will be written as h times u minus 1. Okay, x times u minus 1. So what is x minus x2 equal? It is h times u minus 1. In the same way, let's talk about x minus x3. Okay, so okay, let me write it here. X minus x3 I have to write now. I can write x minus x3 is equal to x minus, this is x3. In terms of, it can be written as x2 plus h, because x2 minus x3 is equal to h. This is x. What is x equal? Our x is equal, okay, our x minus x2 plus h. Fine. So this can be written as our x is equal, as we have already defined, x minus x2. This can be written as x minus x2 minus h. But x minus x2 is equal to h times u minus 1. So this is h times u minus 1, and you have minus h. That's equal h times u minus 2. Okay. So these x values are also following a trend. Okay. So what trend they are following is quite easy to visualize from here. We have x minus x1. X minus x1 is equal h times u minus 1. X minus x2 is equal to h times u minus 2. In the same way, x minus x3 will be equal to h times u minus 3. Okay. So what will be x minus xn then? Because in the expression we are having x minus xn. So x minus xn will be equal h times u minus, then you have 3, that is n minus 1. Okay, that is n minus 1. The question is how, because you have u minus 3. Okay, that is u minus 3. Fine. So you have here x minus xn will be h times u into u minus n minus 1. Okay, that's a little correction I would like to make here. X minus x1, these values are not correctly given by me, so there is a little error. X minus x1 is equal hu. Okay, x minus x2 is h times u minus 1, and x minus x3 is h times u minus 2. Okay, so x minus xn will be h times u minus, you have, when you had 3 here, here is 3 minus 1. You had 2 here, it's 2 minus 1. When you had 1 here, it is 1 minus 0. Okay, when you have n here, it will be n minus 1. That's it. Okay, so these are the values of x1 minus x2, x1 minus x3. These values of x1 minus x2, x1, I'll be substituting now in the given equation. Okay, so as to obtain the final equation. The final equation will be, therefore, I have now, let me write it, y of x is equal y1 plus delta y1 by h into x minus x1 plus delta 2y1 divided by 2 factorial into h into x minus x1 into x minus x2 plus so on, plus delta n y1 divided by n factorial into h raised to power n into x minus x1 into x minus x2 multiplication with x minus xn. Okay, so that is, as I was telling you, this is y1 plus delta y1, as we just made an x1 minus x2 divided by h is equal to u, that is u here, plus then we have delta square y1 divided by 2 factorial x1 minus x1, x minus x1 divided, that is u. Then you have x minus x2, that was equal to h into u minus 1. Okay, h into u minus 1. So you are also having x minus x1. Okay, so this entire term is cancelling out and we'll obtain, I can also write this is x minus x1, as we had already stated, x minus x1 divided by h is equal to u. Okay, so when you have x minus x1, that will be equal to u times h. Okay, plus so on. So you are having your h here, h times u delta square y. Okay, plus so on, plus many terms, plus the last term will be delta n y1 divided by n factorial into u into u minus 1 into u minus 2 into so on into u minus n minus 1. This will be the last term. And this polynomial that we have obtained, this is called, this polynomial is very important polynomial. This polynomial is essentially known as the Newton's forward difference interpolation formula. This polynomial is known as Newton's forward difference interpolation polynomial. Newton's forward difference interpolation polynomial, and I will be discussing its application in the coming lecture. Here I would like to emphasize also upon the this h here at the denominator, as actually what has happened is like we have x minus x1. Okay, this x minus x1 is equal h times u. Okay, then we have here, this is 2 factorial s square, sorry. Okay, then we have x minus x2. Okay, so x minus x2 is written as h into u minus 1. Okay, so this is h square, and this h square will cancel. Same will happen with all these h's. That's why you will not be having any h in the denominator. Now, after deriving this formula, see, the question is all about obtaining these forward difference values. Okay, so what is the question? If you have to solve the interpolation formula, y1 will be given to us. Delta y1, delta y2, delta ny1. This will be obtained once we are drawing the forward difference table. Once we draw the forward difference table, okay, and the value of u is x minus x1 divided by h is equal to u. X1 is given, h is given, so it's quite easy to find the value of u as well. Okay, so what we'll be doing is we'll be making use of this formula to solve few questions in the next class. Thank you very much.